Hiya. Duck, 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 goose. Hello. Good afternoon. It's afternoon for me. I'm looking at some material from an owl pellet. This is the bone of the sort of grindy bits on the jaw of a mouse. We'll zoom out in a second so you can sort of have some context for that. Hey Sam, how's it going? I'm doing well. I'm on my own again, here in the lab. Pacific is now safely back in San Francisco. And my normal cluster of students is also not around. So just actually taking a look at, this is a piece of a jaw of the sort of grindy teeth of a mouse. I think it's a mouse. I need Glorgana here. She probably could tell me what kind of mouse. Is being alone more ideal? It doesn't matter to me. Sometimes it's nice to have company. Sometimes it's nice to be able to just do things. It's good having guests, and it sort of changes the atmosphere. So these are the molars of a mouse, and at the current height that I'm using the scanning electron microscope, which is actually pretty close, I can't actually scan any farther out, so I can't actually zoom out so you can see more of the mouse jaw. So I'm going to actually lower the stage, since we don't really need to be that zoomed in, and that will give us a little bit more viewing space. I think I can actually lower it below this number. I think it'll actually lower it. There. You can kind of see it now. Is this for a rodent dental hygiene project? No. It's actually for my daughter's... hang on a second. Do my shout out over here for Devil and Mrs. J. Hello. And it's not owl poop. Owls eat stuff and then they vomit it back up, right? The parts that were indigestible. And they come out in these little pellets, right? So it's coming out the mouth end. It came coming out the end it went in, right? More like owl vomit, yeah, except for there's not a lot of liquid in it. It's actually mostly like the fur and the bones of things. And so for their second grade class, they got owl pellets. I guess you can just order owl pellets. Um, and then they were supposed to sort through them and separate them into. They had a little sheet with like the outlines of the different kinds of um, organisms that may be included in the pellet. And then they had to pick the bones separately and sort of sort them out as to which ones they were. And I think this is fascinating. As a scientist, I love it. I love that they are looking through, they're doing science, right? They're looking through the pellets and trying to basically identify the different organisms from the bones. So I think that's actually a really nice project. And for a second grade class, it's pretty amazing. Of course, my daughter's in some sort of accelerated program, so it's not like every school in Indiana works this way. But it's a really cool little project that they do. So, and then we brought them in and put them on the stereoscope on the weekend, and I told her I would also put some on the scanning electron microscope so I could take a look at them very, very close, right? It's in the public school program, but they have a gifted and talented thing for students. So let's see. I want to probably rotate it so I can have more of it in the field of view at once. So those are the front teeth on the bottom side of the jaw for a mouse, and just one. I think both pieces of the jaw have like one of the teeth. So we don't have the entire skull in there. It wouldn't fit. But she did actually end up with a whole mouse skull and then some jaw pieces like this. Some of the lower jaw pieces. So, let's see. I want like 85? Sorry, I'm trying to figure out how far to rotate it and which direction. I think this is what I want. It's always guessed the rotation, so. Oops. Yeah, so these are the lower jaw front tooth, and I think for mice they have two, one on each jaw basically, or one on each part of the jaw, or something like that. Or maybe this is the whole. I don't think so. I think this is just half. Obviously not my specialization, but this is the molars, right, that they use to grind things like seeds. "3D Prima, hello." So on Monday, when I might normally have streamed a little bit, I was thinking about trying to squeeze a little stream in, but I just didn't have time. I was going to also look at these because I was instead showing the scanning electron microscope to one of our classes here, anthropology class. And so since I already had to look at, or I was already planning on looking at some of this bone stuff, I thought, oh, they might really kind of appreciate looking at something besides diatoms. So I gave them sort of like a little 45-minute introduction to the scanning electron microscope for research purposes, and basically made it so I didn't have time to stream. Okay, I'm gonna just I'm gonna grab this image. I'm gonna going to build this image. This is a nice one of the jaw. I also have some other things from lake sediments that are in the SEM. So if you look into the little chamber, you can see that there's little SEM stubs, but they're all very low. What are the hair-like objects? It's probably just fur. You know, whatever the owl eats, you know, the bones and the fur aren't really digestible or nutrient providing bits. So I think they swallow things whole, and then they just Ralph up the parts that, you know, like a fur ball, basically. Esterella, hello. Let's see. What do I have? Oh, the Twitch emotes are acting weird for me. Let's see. I've got this little shout out for Esterella, and I should point out I've been kind of running around advertising for Friday night. Esterella is going to be drawing one of her little candy goblins, but it's based off of my daughter Sylvia. So I think she's already drawn it. She's just going to color it during that that stream that she does. So you should give Esterella a follow. She's a great sort of fantastical digital artwork, and I think that'll be a very entertaining stream, especially because my daughter will probably be there. So it's hard to get a sense of how big what we're looking at is, because I mean, a mouse skull, like, you know, there's a scale on the image. If I zoom out, that's 2 millimeters. So, you know, you got a sense of what 2 millimeters is from a ruler, basically. It's very small, but the entire field of view there is about 7 millimeters. So, I mean, big enough that you could pick it up. I picked this up with my hand. And so the little things that you're seeing that are on there, those are actually fur, for sure. And it may just seem like it can't possibly be fur, but I'm pretty sure that's what that is. You know, just challenging to get a sense of it. Same reason cats throw up hairballs. Yeah, they can't really digest the fur. So, let's see. How am I? I'm doing fine. What does Mini Professor say in the sub? What does Mini Professor say in the sub notification? I don't know what you're asking me. What does Mini Professor say? Oh. When you subscribe, it depends on whether it's if it's a new subscription, like the first time, or if it's a recurring one. So I think the first time you subscribe to the channel, it's, she says pay Mallory's salary, because my lab technician Mallory gets paid partly from the lab, from the Twitch stream. Like, so she gets some money from what we're doing here, and so it says pay Mallory's salary one time, and then that other quote that's on there that she says is, we were playing Slime Ranchers or something one time, and she just started blabbing about me, saying something like, Daddy's strong, Daddy's smart, just making like a long list of my characteristics. So it might be that one. It just depends on whether you're recurring or first time. This is Owl Pellet, and I'm going to just tuck this away under the Owl Pellet folder. This is a mouse jaw. And go back to the live image. I'm gonna we're zoomed out is basically as far as I can get on the SEM. I might be able to actually lower the stage a little farther. I don't know what the minimum. I don't actually remember what the minimum value is. I'll try to send it down a little farther and see what happens. Maybe it will let me. No, this is it. That's the minimum because I put a bigger number in than that. So you can kind of see. I'll speed it up, slow it down a little. You can kind of see where it connects here. It's the piece that connects to the bottom side of the jaw right there, and then the molars are here. And I think this is normal for rodents. There's a gap between the grinding teeth that are here and the sort of shredding or piercing teeth, which are the ones in the front, right? Because they just have like a set of incisors or whatever you want to call those front teeth. You can see they have what look to be two complete sets. Maybe it's 3 sets of molars. Maybe it's 1, 2, and 3. Yeah, that seems more likely with a little bit of organic stuff still between them. So we can actually just zoom in and look at the individual molars, which is kind of cool. And then here's how they actually fit into the jaw, right? So we're zoomed in on the rearmost molar of a mouse. And your molar teeth are the ones that you use to grind food with as well. So it's the masticating part of their tool set for grinding up food, particularly stuff that's a lot of animals that have these sort of grinding teeth use them for breaking up things like seeds and things that are challenging to eat that they can't just swallow whole. So it's kind of a nice little view of its backmost tooth. And if you're curious, so I can actually do some really simple measuring on here. If we just draw lines from here to say here, that's the angle's a little off. Hang on. This is about let's see, that's 1.5 millimeters basically, to give you a sense of the scale. And we can also do sort of a height scale if you want. So how tall are they? Something like that's 3/4 of a millimeter right there. So pretty small. Let's see, I'm gonna fix the auto brightness and contrast. The gears on one of the legs on that jumping bug, if you'd it or some other surprising construction mechanism. I don't know what you're talking about, 3D Prima. I'm missing a verb. Which animal? Yeah, it's a dead, I think it's a mouse, not a rat, but I think this is the teeth of a mouse. I think it's way too small to be a rat, but they're closely related. Okay, I'm just gonna snap this image. It's not much of a snap, it's more like take a picture and wait 3 minutes.
Nothing is
get
impossible.
A good sense of it.
Not if you can imagine.
Thank you for the follow, Crixodia. Live rat imaging would have been more fun. Potentially. Missed the first part of the question. Oh, I see. What's the most unusual or weird intuitive part function you've been able to identify? Got it. I don't know. I mean, these all seem pretty standard. They're just jaws of, this is the jaw of an animal, so I mean, we know how it works. Um, I'm trying to think if we've looked at any animals that had really interesting, like, parts to them. Um, Nothing's coming to mind in particular for that. So, um, hey Sarah, how's it going? We're looking at some bones from. Hey Pacific. We're looking at some bones that were coughed up by an owl that my daughter was leafing through. I put some of the light microscope pictures in my Discord under the just chatting. So if you wanted to see what they look like from a stereo microscope, you can check that out. Forgot I put a Discord logo that pops up when I type Discord. We took some pictures of it on the stereoscope. My wife did with my daughter on Sunday. Saturday I was on a field trip this week, and then I just posted a whole stack of different pictures of bones and things. I didn't put all of the bones onto the SEM. I just put a couple of the jaw here of a mouse, and I also have the jaw of a poisonous shrew that we found, a short-tailed shrew that Glorgana helped us to identify. She hopped in and said hi, and told me it was a poisonous shrew, which is kind of cool. One of the problems in the scanning electron microscope is you don't get to see the color. So I think that that's a nice advantage of having both the stereoscope and the SEM, because they both produce basically the same kind of images, which is like the topography of the actual specimen that you have on there. But the scanning electron microscope obviously has a much more magnification power, so we can get zoomed in a lot closer if we wanted to. And the stereo microscope lets you see the color. So one of the things that's really neat about the shrew teeth is that they're very red. And when my daughter was leafing through the material, these things are really tiny. Actually I have a whole stack of them over there. Hang on a second. There we go. So she sorted these out. And then, so the little mouse jaw that we're looking at is, to give you some context for it, for size, that's in my hand, how big it is, tiny. And then that's the tooth right there, that's on the front. So the little molars that we're looking at are these sort of little, you can barely see them, I'm sure, sort of dark area on the inside of the jaws. And then, so she sorted all of these ones already, and actually all of them. And then the shrew teeth have like a bright red color, and she thought it was blood when she was sorting them. She was like, oh, these got like a little bit of blood on them still. Which is sort of naturally what you might think, because they're bright red, and it's just on the teeth. And so when we put them under the stereoscope, that bright red color is still there, and it looks like maybe the blood's inside the tooth, which is weird. But in fact what it is iron. So the organisms have a lot of iron, and it's for some reason concentrated in their teeth. And so that bright red color is present there in the stereoscope images. But when we go over to that sample on the scanning electron microscope, which we'll do here in a second, you don't actually see the color, so you can't see that it's got that pattern or interesting sort of texture to it. So, and then this is just the attachment to the jaw, so the lower mandible attachment. It's here, so it's kind of interesting little components. You can see part of the jaw where it broke right here, where it was connected, right? And then these are like, I think the muscles attached to these. I have to ask Sarah, but I think that's what's going on there. I know it's your profession to look at diatoms, but I do enjoy seeing other things. In fact, if I had an SEM at my disposal, it would be difficult to restrain from looking at everything through it. So that's actually part of what, you know, like I'm not a mouse expert or a tooth expert or anything. But it's kind of fun to just look at things sometimes, and I like to share that with people. So sometimes we just look at whatever. In this case, I'm actually taking pictures to share with my daughter's class, so there's a value to it. And then Sarah says, yes, shrews use their venom to paralyze their prey. Exactly. So it's actually venom and not just poisonous saliva. No, it's actually venom, and it's in the saliva itself. So, yeah. I think it's venom. It's meant to, keep them alive longer. stuck there watching themselves, basically, so they can't escape, right? Yeah, it's a venom. Anyway, so that's really cool. And, it's neat, sort of neat. So this doesn't actually have venom. This is a mouse. This is a mouse jaw. I don't know what kind of mouse. Maybe Sarah would know, but I feel like Lorgana would just be able to like blurt out what it was, because for the shrew, she was like, "Oh, that's a short-tailed shrew." She just knew. But I don't study any kind of like organisms with bones, so I don't know. I haven't had any specific vertebrate information for anything that I had to know since like high school, basically. So. But let's just give you a nice view. Let's maybe do one where we have all the teeth. That's kind of a cool visual. So unlike everything else that goes into the scanning electron microscope that's not conductive, bone is typically not very conductive. So almost kind of hilariously, there's gold coating over these bone jaws of the mice. So I have gold. I've got it. This mouse has a grill, is what I'm saying. They've gotten their teeth with the gold plating on them. The whole jaw, in fact. And so does the shrew. So that's nice. Okay, let's get the picture adjusted for contrast, because we're in a different sort of focal height. And then I'll set it to take a picture. And then I think these will be amazing for the kids. You know, they all had to sort through the owl pellets, I think. It wasn't just my daughter. And but she was the only one who could show up with like, here's these cool pictures of them blown up to like full size. And the teacher does like a little Instagram post with the kids just for the parents who are in the class, so you can't get to it, but I can, to keep things safe for the kids. But they posted my daughter with like the pictures of the bones, and like she was giving them a mini lecture, the SEM or the light microscope or something. I don't know. It's not Hatchimals this time. Oh, what happened? We got raided. Soundscape. Hey, Zound, how's it going? I'm basically Professor Midas. Yes, I have a sputter coating touch that I put a really fine coat of gold over everything.
Nothing
It's
is
a great way to think of it.
Not if you can imagine it.
KS Ben says, amazing how organisms use these elements that are just everywhere to live. Iron. Yeah, the iron is really strange. And I don't know why, what's with the iron? Do you know, Sarah, like why they need iron or why they have it concentrated in their teeth for those shrews? Is it something to do with the materials that they accumulate to make the venom? I hope you're doing well, Zound. I could give you a shout out, and I see that Dell has also arrived, so I can shout Dell out like this, and I can shout out, just do my own shout outs around here now, like, you know. Oh, you already did it. Thanks, Dell. I didn't see that you had snuck in here. Just came in with him. How you been doing, Sound? I see you sometimes still streaming. Were you doing marbles or something? What were you doing? Does it tell me what you were up to? Heg Pets. Welcome in. Just trying to catch up on the raid that came in. So what we're looking at right now, for people who just came in for the raiders and people who've just arrived, is and this is bones from a mouse jaw, the lower mandible of a mouse jaw, and these are the molars of the mouse, so that the teeth that they use for grinding, and we're looking at it in the scanning electron microscope, of course. So this came from an owl pellet. So owls regurgitate stuff that is indigestible, and so fur and bones, this sort of thing, basically comes back out the way it went in, and then apparently they sell owl pellets as a lab thing that you can get. So my daughter's school had a bunch of owl pellets that they had to dig through and sort the bones for. It's really late. Yep, I know you're coming from the other side of the world. Thank you for bringing your people in for a raid. Very cool. And hopefully we've got something cool here for some of them that they can check out. Dell's being sneaky. This is molars 2. All right, so we've just been looking at, for like a half hour now, one mouse jaw, and let's move over to the shrew. So this is the jaw, the mandible again, lower mandible of a shrew, and in the stereo microscope, these teeth are the ones that are red, especially out here at the tips of them. So it looks like they have blood on them, but it's actually just iron, as we were mentioning. And let me get the rotation. So I think I want to bring it back maybe 30 degrees. Let's see what that does. And then we can get most of it in the field of view at the same time. So like with the mouse jaw that we were just looking at, these are the front teeth, or one of the front teeth. The other one's, I think, on the other jaw. And then these are the teeth they have instead of grinding teeth, because mice mostly, they can bite, but they mostly eat like seeds and cereals and stuff like that. And shrews are clearly things that eat flesh, so they actually have these really sharp, nasty, jagged teeth instead of those flat, grindy teeth for chewing things. So it's a primary difference for them in terms of like what food you eat usually determines what kind of teeth you have. For humans, of course, we have both kinds. We have teeth for both rending flesh and for for grinding things because we've adapted as omnivores to eat a wide range of foods, partly responsible for our success in the sense that we're generalist in terms of our food supplies. Maybe I want it to be a little farther back than it is, so let's see, 155 maybe? Just trying to optimize my image. Oh, I almost can get the whole thing in. Let's see. Got the whole jaw in there. That's nice. Okay. And it seems like it's in focus still. Perfect. So I can get one sort of overview shot of it, which would be nice. Again, mostly for the kids. But also for you guys. Let's see. Just go ahead and click that, and then I can see what people have been doing in chat. You're going to start selling owl pellets? You have a small collection? Excellent. Where did you get your owl pellets from? From Dell? Do you have an owl on your property? Or do you just have a lot of trees where the owls live? Because I never get to see owls, and I love owls. I'm a birder, of course, as most people know, if you've been to the channel a lot. Did owl pellets in 3rd grade in Illinois, and then in 7th grade in California. Yeah, so we're in Indiana here. My daughter's in 2nd grade, and I think they do a lot of the 3rd grade activities in 2nd grade because she's in the accelerated program. So, you're going to have a small collection. You didn't know you could use an SEM at such a low magnification. Yes. Well, so what we're looking at is still very small. You know, the whole thing fits in my hand, in that I can pick it up with tweezers or very carefully with my fingers. But if you look at the scale bar on this image, it's the whole distance across it is 8 millimeters. So it's still pretty small. I mean, 8 millimeters, less than a centimeter. Really, you can put anything in the scanning electron microscope if it fits in the chamber. So you can actually look at some fairly large things in the scanning electron microscope. It's just that unless you're looking at microscopic structures on it, it doesn't really make a lot of sense. And we looked at this on a stereo microscope with my family, my daughter, my wife, and I. And you could see almost all the same things we could see with the scanning electron microscope, but I'm going to give you an example of something that you can't do on the stereo microscope in a second. Because the object fits in this SEM, we can obviously look at stuff in the SEM with it, but you find them all over the place. Also, welcome in, Parkerzilla. The dark side is powerful. My former boss has owls in his barn, and he provides the pellets to local schools. Well, that's amazing. Does he charge them? Because Dell wants to make some money here. Live in an urban forest. I never see owls. And I don't know why. I mean, my neighborhood has monstrous trees, and every once in a while I hear an owl outside, and then I go running out with my camera and a flashlight, and I can't find it. So they have flown over me before. They make no noise when they fly. Owls are extremely interesting night predators, and they make no movement. Like when a bird flies over you, like I've had hawks buzz me before, you hear it and you feel it. With an owl, you just see it. Like it just flies over you. You don't even know it's there. And if you're not like looking above your eye height, you won't see it at all. You won't hear it or see it. They are really silent when they fly. It's amazing. And part of why they're so successful, right? One of your favorite elementary school science activities was looking at pond water under a microscope. Well, This is what we do. It's still my favorite activity. It's like I've never gotten out of second grade or whatever it is, you know? Only I'm looking at things with the scanning electron microscope. So this is a short-tailed shrew jaw. All right. So yeah, you can put bigger things in the scanning electron microscope. We could potentially zoom in on an individual tooth, which, you know, like in a stereo microscope, you could probably get this sort of a view. So just for clarity, we're zoomed in. We got a lot more detail and resolution than you can get in those type of a microscopes, but we're at 200 times magnification right now, which is still, you know, something that you could do in a stereo microscope. What you can't do if you want to see the scanning electron microscope flex is to see this little tiny chip in the tooth. You know, let's go look at the inside of this little chip in the tooth. That's not something you can do with the stereo microscope. And we could actually look at the structure of the bone here in the tooth of the organism. So definitely not something you would be able to see in a typical light microscope. We're already at 2,000 times magnification. So sometimes larger objects are kind of cool to look at in the scanning electron microscope, just because you can then have the context for the smaller things that you're seeing. Before the stream started, I was sort of playing around looking at the teeth, and you could see these little tiny structural striations or whatever they are in here on the outside of the teeth that I thought, or in the inside of the teeth rather, that I thought were pretty cool. Which is probably just the growth of the calcium phosphate, you know, the actual like mineral that makes up the teeth, apatite. And then there's some junk in there, but that's probably just stuff that got trapped in there. But for clarity, you know, here's this piece of the tooth. We're zoomed in on a tiny little chip on the tooth, right? So, you know, the kind of detail you can get is completely different. If we ran into pollen grains, we would be able to actually identify them on this microscope. So I'm just going to get a picture with the little tooth with a chip in it here. And I don't think I can do much better with respect to composition because of the weird angle. But I'm just going to go ahead and collect that. So it's kind of nice to be able to have that context, I think, though. You are legit thinking about going to a garage with a bucket and a shovel and collecting some guano. Okay. Free nitrogen. Yeah, it's actually phosphorus, too, in bat guano and penguin guano. He gives them to the school for free, but then he's very rich. Well, that's nice of him. Yeah, literally no noise. I saw a great test with microphones. Yeah, it is completely spooky. Like, to see an owl fly over you. It's like, what was that? So, kind of neat. The shrew is doing pretty good for itself, minus the chip in its tooth before the owl caught it, I guess. Because its bones look like they're in pretty good shape. But it's I think it's kind of neat to be able to see it. This giant slideshow is kind of distracting. Move it over a little, and then get rid of this little swatch. Right there we go. Let's see if I can also move the chamber view over a little. So this really bright edges around the cracks give them a lot of definition, but they're sort of an example of a little bit of a charging that happens associated with edges. So in the scanning electron microscope, the edges are places where the electron beam hits the surface, and then they kind of move over the surface, and they accumulate oftentimes on the edges. So the edges end up being these really bright parts to them. Here they actually make the cracks in the teeth look spectacular, but sometimes they're annoying because it makes it difficult to image the picture correctly. So I'm just taking this picture so that we have sort of a close-up version of the tooth, and then I'm going to kind of zoom back out so we can see that in context. I thought that would make a nice example for the students in my daughter's class. She's going to show up with SEM images to share with them or post them to Instagram or whatever the teacher wants to do with them. And we can have one of the whole tooth. So, you know, these are like little tiny bear teeth, basically. They're just used for rending flesh only. They don't have the flat surfaces for grinding. They don't have the sort of thickened enamel surface that molars have. And these teeth don't grow constantly, right? I think that's what separates the mice teeth from these kinds of teeth, is that they are constantly growing and they have to chew stuff to kind of like wear them down. So did I gold plate the bones? I did, Freya's. I had to because bones are not very conductive. And so I have little tiny gold-plated shrew teeth. If I could only make a tiny necklace, and I could wear them, you know, be very stylish with a gold tooth necklace. I was able to look at hydroxyapatite under the SEM at low kV with no coating. You can. The problem is I don't really like to switch the accelerating voltage because it takes a long time for it to recalibrate, and sometimes it doesn't do a great job. But you could probably do these in a low accelerating voltage. Also, this is although I've never used it that way, this SEM also has an environmental mode where it has low vacuum. I just don't have a whole lot of purpose for low vacuum mode. I guess I could probably, if I picked some tardigrades and put them on a stub or something, I might be able to put it into low vac mode and not have them completely smush, but implode. But I haven't figured out how to actually pick the tardigrades out and put them on a stub. And I don't know if I want to do that. It seems like a lot of work. But, you know, if I wanted to look at something in environmental mode, that's an option in here. I never use it, so. Horseshoe crab looking thing on the tooth. Oh, like right here? Right here? I think it's just a fragment of fur. This is the fur. Actually, let's zoom in and look at some of the fur while we're here. Because the owl just barfs out whatever is indigestible. So fur balls, and it basically is like a fur ball with bones in it, I think, when the pellets come out. I actually didn't get to play with the pellet at all. My daughter had already separated into bones, and some of the bones still had the fur on it. So this may be stuff that was, the fur was still stuck on the bones, or it may be transferred from some of those things that had the fur still on it. So I can't say for sure whether that's shrew fur or mouse fur or who knows what else might have been in the owl's belly. I think I've told this story before. That there's a story, if you go, I think it's on Wikipedia, where they were doing an autopsy on an owl, and so they had opened up the owl's stomach, and what they found inside of it was a smaller owl that it had eaten, and then they took that owl out, and it was recently dead, so they did an autopsy on it, and what they found in its stomach was another baby owl. So like there was it was like Russian nested dolls with owls. So there was a little one in the stomach of the bigger one, and then the biggest one had eaten the smaller owl. Nasty. They'll just eat anything, right? Including other owls. All right, let's go look at some of the fur. I think it's actually a crazy story, but it was from, I think, the 1900s or something. I don't remember when that they did it, but you can see the scales on the fur here. So let's see if I can get that in to a tight focus for us. So you can see the actual structure, little scales of fur. Which I think looks kind of interesting in the scanning electron microscope. Probably not what you were expecting for fur, but I'm pretty sure that's what that is. So, look like little tiny scales, basically. Owlception, yes! Matryoshka owl. Nesting owls. Yeah, it's some sort of fur, just from the structure. That's what I would guess, and also, it's on the shrew itself. Pretty nasty. Owls they'll just eat anything that they can, you know. Including other owls. So, I wasn't expecting to take pictures of fur, but here we are. The Tescan Vega links on the Tescan site don't work. I don't know what to say about that. When I open up... maybe they're doing away with the Vega 3? I don't know. They have newer models. Actually, they have these cool pictures up on their webpage of things, and my pictures are better than their pictures, so I'm just going to throw that out there. I don't know what their problem is. Were you looking for something about the specs? Is that what you wanted to know, like something about the specs for the instrument? Because I guess I have a manual around here somewhere. Not that I ever use it. You know, one thing that this SEM does that I've never used, there's an option on here for somewhere in the tool sets is an option for making a 3D image, like the red and the blue images that are taking 9 degrees apart. So if you put on the 3D glasses, basically it looks three-dimensional, and it has some ability to do that. This instrument does. I've never used it because one, those red and blue glasses kind of give me a headache, and two, it sounds like a lot of work, but you can tilt the stage 9 degrees pretty easily. So you could just take a picture, tilt the stage, and take a picture. I think that's all you do. And then one of them's red and one of them's blue. And then it puts it together in your brain the right way. But I don't know. I don't remember. I haven't actually looked at how to do that. So, but it's kind of a neat feature. Maybe one of these days I should figure it out. Shrew jaw. Okay. Let's look at the Toothy Tooth, this part, which is probably where, it's probably this tooth. I don't know. I guess they use this to bite things. Maybe this is where they inject the venom. Doesn't look dissimilar from like claws of insects we've seen actually before. Doesn't seem all that sharp. Well, at least it's easy to find things and take pictures of them in this little pincher. Yeah. Well, usually, like, back teeth are for holding things and rending flesh, and front teeth are for biting things. So I'm guessing if it injects them with venom, it's got to be the front teeth that do the biting. Trying to see if Glorgana was on. She posted a little link to the venom producing shrew that is responsible. That's the jaw for this thing on our Discord as well. So it'll tell you a little bit about the venom if you're interested in shrews. You know, they won't have SEM images, but it will actually talk about the animals themselves. Oh, that's weird. One of those emotes doesn't show up here, but it shows up there. Alright, well, I think this is all that we'll do for the bones. And now I've got to figure out what we'll look at next. This is front tooth, shrew jaw. Let's see. So let's look at the material from. This is what we're calling Tanglewood Lake because it's on a road called Tanglewood Road. I don't know that it actually has a name. I went and looked for a name for it on, Google Maps didn't have a name for it. There's a lot of little lakes around Terre Haute that are just places where they dug out coal mine. They did surface mining for coal. And rather than remediating the sites, like actually remediating the sites, what they do is just put water back in the pit, because if they put soil down, soil actually has a whole bunch of regulations, but if they put water in there, then it's a lake and it becomes sediment, and there's no regulations for lake sediments. So in Indiana, that's a trick that they use to try to have to avoid doing any kind of remediation. They just put water in there, and then oftentimes they turn them into parks, and then people come and hang out at them and fish and whatever else. And the underlying environmental problems might still be there in many cases. But the water itself usually will bury them pretty quickly. So that's one nice part about that, is that if there are environmental problems, they won't stay that way for long. So I just want to tweak the stigmation a little bit since I've got little holes here. That's the surface of a Pinularia. It's a diatom. You can see it's a little dissolved. So we were calling these the samples demon blood samples because they smelt terrible. They smelled like sulfur, of course. So now that I got it into focus, I'm going to raise the stage up, which makes things look terrible for a couple of seconds, but we have to get it back into like operating range for diatoms. We were zoomed way out for the other things. And this will actually help with the image quality quite a bit, to be able to zoom in a lot closer on the very small stuff that we'll be looking at. For people who were here for the stream last week where Pacific was here, that's one of the two scary things that happens on the SEM, is that you have to raise the stage up and you can give it information that could potentially be not good, and then it will destroy the instrument. So worst case scenario. So usually it's the part where I'm setting up the SEM that I do for people before I let them use it, and then I'm like, just don't touch these things. You could also rotate it into problem if you're looking at samples like we are now, where they're at two very different heights, because it knows what the height of the thing that's directly under it is, but it does not know the height of the thing that's in the adjacent carousel spot. So if you set it to the height where it's safe for what's right under it, and then you rotate it around, you could rotate it right into the pull piece, which is potentially bad. Potentially catastrophic, actually. It's a good way to destroy the scanning electron microscope. All right, so we're a lot closer. We have a lot less depth of focus as a result. There's that Pinularia, and we can just zoom around in here. A lot of this stuff in here is junky debris. I rinsed these samples so many times to try to get the muds out. And I think actually probably took out some of the diatoms in the process, because mostly what I see in these samples when I was looking around in it earlier is very large diatoms. So Some of them are very cool, but there aren't a lot of little tiny diatoms, which means maybe they were in the mud, or maybe they had a hard time getting them extracted from the mud when we were processing them. So we saw something like this last night. If you're in Pacific Plankton Stream, this is a Gyrosigma, and I moderate for Pacific Plankton, of course, and she was here when we collected the sample. This is actually from the core that she collected while she was here. And ooh, that's cool. The little pore coverings on the areolae are almost clear. Right here. So we're at 92,000 times magnification, and that image is not bad for 92,000 times. You know, looking at something at 100,000 times is usually kind of pushing the instrument to the limits. We can see that these little holes, which are the areolae, and the rows of them, which are striae, you can see there's like a little covering over it. That's a good sign that we're in clear focus. So there's the whole organism. It looks a little bit like the Dairy Queen logo, in that it's sigmoid in shape. This is Gyrosigma. It's a Raphid diatom. The raphe runs down the center of the valve, but its rotation, its symmetry is rotationally inverse. So there's an S-shaped curve here and an opposite S-shaped curve here, but they're twisted basically, and then they're symmetrical. So you can't fold it this way or this way, but you can fold it if you had a mirror, right? Sort of a mirrored reversed image. Let's see. I want to go plus 20 maybe for rotation. Try to get the whole thing in. That's a good guess. And Gyrosigma are actually benthic diatoms. They usually are what we call epipellic, in that they live most commonly on the surface of mud. Like that's their more common habitat where I find them. But they may live on anything because they have a raphe they can crawl around. These ones were collected from very deep water from a canoe, precariously collected by Pacific Plankton and I, trying not to fall in the water. And because canoes aren't really the best boat for collecting a core. So I'm going to get this equalized here, and then I'll start a picture. So I wanted to get some pictures of the diatoms from the lake that we collected the core from for a couple of reasons. One, to see what was there, to share with Pacific Plankton from her visit here, and then also for her and I to share with her hosts while she was here, who very graciously lent us the canoe and allowed us to go out on their lake and collect a core, which I think is a very, for people who have nothing to do with science, that's actually very generous for them to allow us to do that. So, hey, Pacific Plankton's here. Good timing. Demon blood samples, exactly. Just got out of class. Okay, good. You just missed the stuff with the teeth and the jaws of the shrews and the mice. So, you've seen those in light microscope. So we got some close-up images of those, and that was it. Yeah, we were calling it demon blood because it's the smell of sulfur, and the fact that when I was transferring it from the bags where we had chopped it up, it looked just like black ichor. The mud itself was very dark. So, yes. And then the aroma, the smell of brimstone and sulfur was persistent. So, it was a nice short canoe trip. We were out and back in, like, I want to say it only took us about 10 minutes to collect the core. I don't think it was, I don't think we were out there for very long. It was a short trip. All business, you know. We were trying to get back to get stuff done for the day or something. So we went out, grabbed the core, came back. It probably took us longer to like load up the canoe and unload the canoe than it did to actually like use the canoe. And then we collected the core first try, or rather Pacific Plankton collected the core. I didn't do anything except for watch and use my magic finger to tell her what to do. And then you spilled it all over the driveway, you know, accidentally, because I sabotaged the core tube accidentally. But actually, that probably saved us a lot of time, because we otherwise would have had to section the core all the way to the bottom, which would have added probably another 45 minutes to the core sampling. So, sabotage. Yeah, so Gyrosigma. And then we can take these pictures and share them with her hosts while she was here. It doesn't look exactly like the species you had last night. It's definitely a different one. So there's a little piece of a diatom in that mud. Right here. Gotta put it in a different folder. Tanglewood. Oh, there's a cool little diatom I didn't notice. Not totally sure what species that is. It's not a Navicula. It's hiding in the shadows. Uniseriate, non-linealate, so my first guess is always Celophora when I see that. Could be something else. I know if Anna's here, she'll be like, you always think it's a Celophora. That's because it's always Celophora. Not sure what that is, actually. But it's under the shadow of this giant piece of junk right here, which makes it very hard to get a clean image of it. There's another little diatom over here. That's a star anise. Hey Luke, how's it going? Realize that I have to start to diet. Well, that sounds terrible. You could just work out a lot. That's what I do. Doesn't always help. Still getting fatter, but slower than I would if I didn't. Plus, we went on this field trip over the weekend with my students for my class. It's the first field trip that we've been on since since the pandemic happened. So that was nice because I like to go on field trips for my classes. And Melisira. And even though it's Indiana, it was very sort of steep terrain, believe it or not. And they were all huffing and puffing to get up the steps and to get up and down the cliffs, and I just sort of ran up them like a mountain goat, and then patiently waited for them to get there, and then pointed out how old I was relative to them and how out of shape they all are. Because that's fun. There's like a bunch of cool little diatoms here on the edge. This looks like maybe it's a Diplones. I'm not sure. This looks like Diplones, though. Like a long, skinny Diplones. Or, oh no, it's a Pinularia. Yeah, definitely Pinularia. Oh, there's a little tiny chrysophyte scale on it. The scale from a chrysophyte cyst. We saw some chrysophytes in the live material, and then also I think we saw some scales from chrysophytes too. We also saw like a butterfly scale. I was hoping we would come across something like that in here as well, but haven't seen anything yet. Pinularia. Yeah, see, it's got these big chamber-like striae with a whole bunch of holes over them. This is how you tell. I don't know what species, because there's a lot of Pinularia, and they're all fairly challenging to try to break out to species. This is an Amphora. If Hannah Rebecca Music shows up, she sings about Amphora and about how it shows up frequently in our samples. This one is Amphora. So Amphora as a genus, this one, the other valve is missing, but the girdle bands are all here that would normally connect it. So the whole frustule would have another valve that looked like this one on it. And if it were present, this structure, which is the raphe, would also be present on this side of the diatoms. Both of their raphes are basically located on the same side of the diatom when you see the whole frustule. And the other side, if you looked at it, wouldn't have a raphe on it. So they use this side. This is the crawly side, basically, for the diatom, and the other side is the non-crawly side. I guess I could probably take a picture of that. So I lowered the beam intensity from 10, which is sort of our scanning around speed image in beam intensity. And then I need to rotate the image. Maybe like this. Pretty good guess again. Just gonna work on the focus a little bit. Mustachioed. You want to use the mustachio and not the googly eyes? Let's see. I think I have options for mustachio today. let's first get the image started, and then while it's doing that, I'm going to show you what kind of mustachio options we have. There is this one. Yeah, I've got eyes. Isn't it in the choices of things you can spend money on in the channel? There you go, googly eyes, exactly. Hang on. So, let's see, if I undo that. Yeah, I've got a Fu Manchu style mustache now. And I've got the classic French curl here as well. So you have to decide which type of mustache you'd like to see. Reading is hard. Also, we can change the color if you don't want brown. This is like a ruddy brown. But we have a Fu Manchu now. This is an option, so... I haven't gotten a Groucho Marx. I've only got these two mustache options. So, Pacific, you've got to make a decision. You want the French curl, okay. And then I'm going to hide this. And then I've got the color's okay. I don't know if you want a specific color. I need to edit transform. What did I say for the rotation? Oh, I see, it's a 350. Let's see. Well, we need to at least get it around the right way. Still need some bit more rotation. That's a little crooked the wrong way. Let's see. It looks like maybe it's around a 130. I could go a little farther. That's pretty close. You know, it's maybe needs another degree. Hang on. Be patient. Your mustache is cooking. There we go. That's definitely the right, yeah, it's Amphora. I thought you'd appreciate that, Hannah. Let's see. Let's put this under Amphora. How is it you knew? Amphora. Okay, let's zoom this out a little. And then I can put the mustache on. Do you want the mustache, above the Rafie? Like this? Like here? Probably a bit smaller. That's a little too big for that diatom. There we go. I feel like that's a pretty good size. And then you also wanted googly eyes. Oh, can I make two of them? Let's see. I made them separately. I think I can just copy and paste it. Yeah. There we go. I made two of them so that I could rotate them. Something like this. Where did the other one go? Oh, googly 2. There we go. Let me... I'll move this one over here. That's good. One eye is good, two eyes are better. Okay. This way, the reason I did 2 separate ones is because I thought it would be sort of fun to, let's see, we can make this like 90. There you go. True googly eyes should have the ability to have them not be quite perfect, right? Like a little off, they're googled, right? This completely googled eyes. I feel like we did a great job with that. What do you think about the mustache? Let's see. What can we do? Cookie Monster. I think there was a... Oh yeah, it's a filter that I have on here for the color. So... one of these things. Oh, there we go. We can make it kind of oranger, or we could make it a little bit darker. I don't know. You're at the doctor. You gotta go. Okay. Maybe a little darker, like this, right? We'll do that. There we go. Pretty good, right? Too many choices. Well, you spent 10,000 of your attack points, and this is what you made. Is this mustachioed monster, which I think looks great, by the way. I feel like if I colorize it, I may just go ahead and put the French curl back on it, you know. Really has the sort of seriousness that a true diatomist would enjoy. And I don't know why we don't put googly eyes and mustaches on all the diatoms when we publish species and stuff, just as like a, here's a one extra picture for funsies, right? I got some good googly eyes, though. I think these are some nice, you know, because I can put them however I want. And I feel like we did a good job with it. You can see what happens when you don't have the mustache, right? I mean, that fundamentally the mustache makes the googly eyes look better. I think everybody in their right mind would agree. Mustache definitely makes the googly eyes. Right? Without the mustache, you're like, what happened to Dad? Like, why does his face look so weird? With the mustache, things look normal again. All right. I may need some toupees. That would be hilarious. Without the mustache, it looks like a hamburger. Exactly. Who wants a hamburger that looks back at you? The Hamburglar. Oh, that's even worse, because I think the Hamburglar steals your hamburgers. Or does he steal your French fries? I think he steals your hamburgers. But actually, I think you're thinking of Mayor McCheese, because the Hamburglar has, like, I mean, he looks like a thief. He's got, like, he's been in jail, but he didn't take the jail clothes off. He's got, like, white striped shirt and like buck teeth, and I think you're thinking of Mayor McCheese. And Mayor McCheese might actually have a mustache. I think we'll have to look that one up. But he has a hat, of course, he wears. A hat would be another good option to add. If we could put hats on diatoms, I think, you know. Okay. Burger trivia. They don't give you Mayor McCheeses or Hamburglars anymore. I don't even think they have the animal cookies with the McDonald's animals anymore. I mean, I think all the options for those characters are really not present in most of the McDonald's. You know, you're old if you followed that last little bit. Google it, kids. You got enough things that are for you. This is for us. Okay. I feel like we did it. We did a great job with it. Maybe what we should do, though, is we should just see, does he look better with the Fu Manchu? Just for reference. You know, I feel like we should compare, right? I don't remember what the rotation was. 132, 133, something like that. We'll start with this. So that's a little big. That mustache is a little big for that mouth. Fu Manchu, though? I mean, I think he could probably rock the Fu Manchu. I feel like he could get away with it. And also, it doesn't make him look like Mayor McCheese anymore. So, nothing can kill the grimace. You like the French curl better. Yeah. I agree. I think maybe the French curl looks pretty good. But the Fu Manchu gives it a different appearance, you know? You want it with both. Why not have two mustaches? I mean... Alright, here's what it would look like if he only had one eye and a mustache. It's a good thing he has two. I feel like maybe that's a little scary. Okay, that was good. A goatee would be good. A mustache plus goatee would probably be, you know, a nice combination. A little imperial just by itself might be kind of cool. We'll see. We'll see. I'm here for you. You want to put things on diatoms or other things, we'll pretend that they're dolls and we'll dress them up however you'd like. Okay, that was cool. Little picture of an amphora. This is the only place on Twitch where you can put mustaches on diatoms. I'm just going to tell you that. This is... Yes, we have an SEM, and that may be unique, but we also have mustaches. And when other people get the mustache technology, they probably still won't have the diatoms. So... Oh, it's a bunch of little Melisairas. There's the cap by itself, and there's the other part of it. It's like this part broke off and landed over there. We can zoom in and look at the surface of the Melissaira. It's got a bunch of little... It's got like a coating of little weird spines on it. Neat. Okay. So that's Melissaira right there. Melissaira are known for flowing water, and the lake that we cored did not seem like it had much flowing water in it, but it is the dominant diatom that we see in this lake. So maybe there's an attached stream that we just didn't see. And there's also a lot of Pinularia, so this is again a Pinularia. This is the whole frustule. One of the valves has been like squished into the other valve, so the girdle bands are now sticking out over the outside edge. But that's a Pinularia, the same one that we've been looking at, but that one wasn't dissolved. This looks like a little like the plant hairs or plant root of some type. Like the little things that come off of a thistle. This is another star anise, a smaller one than the one that we've seen. But that's also star anise. And look, a little tiny... It's a little tiny diatom fragment right here next to it as well. Not related. Stuck in the mud. There's another star anise there. The larger one that we keep seeing, and there's a Pinularia again. It's a piece of a Nitsia. Not surprising that a lake full of demon blood would also have Nitsia in it. This is the Raphy up here on the outside edge. Can't see the Raphy, but that's where it would go. Samples have a lot of debris in them. Some of it's clays. A lot of the clays have been rinsed out because I rinsed these samples like 15 times. And they still had some clay in them. There's some Fragillaria. We saw some Fragillaria crotonensis or something like it in the modern material. There's a bunch of little Fragillaria fragments in there. Oops. I saw another diatom up here a second ago. Something very small. A bunch of little diatoms, actually. That is a Diplonese. There's some little ones up here as well. Little tiny diatoms. That's an Amphora. I think that's maybe a Nitsia. That's another Amphora. There's another Amphora up there. Just little pieces of them. But this Diplonese might be actually really nice to look at, even though it's tiny. They have a lot of really interesting structure on the valve face. The French Manchu. Okay, let's see. I've got this little tiny bit of cribra on the valve face here that I've got in focus, and I got the beam intensity down to 6, and I'm just gonna play with the stigmation a tiny bit because that's the thing I do when I can, and see if I can get it just a little bit better. It's pretty nice. And then we can see all of the detail. And if I slow it down and we get rid of the darkness in the image by fixing the brightness and contrast settings, hopefully we'll be able to see all those little cribra very cleanly. And then these little things that are on the surface here are granules. They're little silica deposition. Let's see, I want something like this. Ah, back to the angles. Always trying to turn things around the right way. That's my, I think I probably actually didn't turn it quite far enough back, but it's close enough. If I'm plus or minus like 3 degrees, it's probably okay. Here you can see all the cribra on the outside edges of these now. I think that's really nice. I think this will make a nice photo that I can share with the hosts of the lake, people that host your Airbnb. I'll colorize it, of course, but I think this is going to be nice. How far down the core was this? That's a good question. These samples are bottom +1, bottom +2, and 9 to 10, so they're all at the bottom of the core. I don't actually remember which one and whether I put them in a specific order, but I think this one came from the driveway. Driveway sample. Yeah, driveway diatom, best diatom. For sure. What you can see from this image, if you look very carefully at it, is here, these clusters that are all together, they look like one big piece. But as they start to get away from the edge of the mantle of the valve, they actually break into two separate little rows. So there's a row and there's a row. And it's only because they get close to the edge and the cribra gets bigger and bigger as it gets towards the edge that they sort of blend into one piece there. And this is what we would call biseriate. So each one of these is an areole with a cribra covering it on the outside. And so each one of these little circles would be a dot. In the light microscope, you just see one dot for each one of these. And what you end up seeing, because it's so small, you probably would just see an extra thick line for most of it, but maybe you'd be able to distinguish some of these where they break out on their own. And then here it would just look like it got extra big around the outside edge. And then this structure that's between them is a costi. So between each sets of two rows of areole, we have a costi. So striae, striae, areole, striae, striae, areole. And then this is the raphe structure on the diatom. It's got some junk here, which makes it so we can't see the end on that side. But you can see on this side, it terminates without deflecting in either direction, so that's a clue for us for figuring out which species this is. There's no deflection on the terminal ends of the raphe. And the proximal ends, the ones that end in the middle of the valve, dilate but very, very slightly. And then this is a characteristic of a lot of the Diplonese. They have this sort of depression that the raphe sits in that makes the raphe look bigger in the light microscope. So the raphe looks like, when you have it focused in the light microscope, it looks like this is the raphe, but it's actually just a little depression that the raphe sits in. And then Diplonese characteristically have another field of areole that run basically along the raphe like a landing strip, and that's what you see here. Is there's a little landing strip of larger pores associated with the central canals. This is a Diplonese. I don't know which Diplonese species it is. I'm still waiting for Itzy to send me my Diplonese book, but it might be in there, and then I would have an idea. That's a nice picture, though. For something that we just saw more or less in passing. As I was looking for other things. But there's these little tiny pockets in here that have all kinds of diatoms. So there's some sort of chain-forming fragilarioid, probably a Starosira. Hidden here is just like a little blob in the mud. And then there's some more here, hidden in the mud. That's a chain-forming fragilarioid again. Starosira, probably. Just barely visible because they're nested in these like piles of mud. There's another little diatom here, also covered with mud. So the mud's clumped around the diatoms, makes it hard for us to see them. Normally I just say, oh, we would rinse it out, but I rinsed this one so many times and I couldn't get all the mud out of it. It was a Nitzia. Probably what you would need to do if you were trying to do this to get that extra bit of mud out would be sonicate the sample, which would vibrate it and break some of it up and allow us to get these clumps of mud to break free. And you can see there's still quite a few diatoms trapped in the mud. That's, again, a Pseudostarosira, or a Starosira. I think it's a Starosira. And there's another one here, Starosira. That's just a fragment of a diatom. Some more fragments of diatoms over here. Just in a little clump of mud. And so, in the light microscope, we'd probably be able to see around the mud, or see through it, and still see the diatoms. In the scanning electron microscope, because it looks at the topography, instead of looking through the sample, we're stuck with whatever we can see. So, but it's easy to overlook stuff that's trapped in the mud in the scanning electron microscope, because here all the little stuff is basically in these clusters. Very little material is sort of sitting out on its own in these clean areas. Pinularia on its side. Pinularia very large diatoms typically. And in girdle view, they just look like rectangles, but in valve view, they can have more rounded edges, often do. Or they can even be undulate margins. Another Pinularia. Yeah, we didn't sonicate anything while you were here. I guess we could have tried it, but, you know, so many things we could have played with. We just went with the easy ones first. It's a star anise. The sponge spicule, a megasclera. It's a little gomphanema. So little C-shapes on the areolae, on the pore covers.
Good news, everyone!
Which will be more obvious in a second. So this will be a good example of why we switch beam intensities. So it's easy to see when we're zoomed out. The beam intensity 10 allows us to see clearly because it makes it bright enough for us. You can see how much more detail is visible when we decrease the beam intensity, though. We can now see a lot more of the detail of these little pore covers that are here. You can actually see that there's some degradation in the silica even from these. And of course, getting it into focus is more necessary the better the quality of the image is. This little dot right here is a stigma. Here's the raphes. These are the striations, the stria, and then there's a little areolae that are covered with sort of C-shaped pore covers. And this diatom is Gomphanema. It is bottle-shaped, like a Coke bottle almost. So it's symmetrical across the axis, or rather along the axis, but not across the axis of the apex. It has an obvious foot pull and head pull, and if we zoomed in on this end of the diatom, you'll see that there's a little apical pore field. There we go. So we know what to expect when we're looking for the right kind of diatom. This is Gomphanema always have an apical pore field because they often live attached on stalks that come off of the apical pore field. And you can see how that's clearly different than the areolae that are here, that are these C-shaped things. A good traditional Gomphanema. All the sort of characteristic features you'd expect to see. Again, nestled in with a bunch of the silt particles here, so kind of hard to see. I did want to get a picture of this star anise, though. So raphe structure, it dilates a little bit in the center here. You can see that it expands. It's not deflected in any way. This structure here, that's like the bright spot on the SEM, is the staros. It's a thickened piece of silica. On the inside of the valve, it's also that way. This is the outside. And then these little sort of dash-shaped areolae make striae, right? So really little skinny uniseriate striae structure. If we zoom out, you can see the whole diatom. And if I zoom in, look at the apex, you can see at the apice, here's the termination of the raphe. It comes in, and then it actually comes right to through this area. Here it is. All the way down on the mantle, and then continues to here, which is where the girdle bands are that connect it between these two diatoms. So it comes in, slightly deflects, and goes all the way around, and actually curls back a little bit. Kind of neat. You can see the dash-shaped areolae. And in this view, you can actually see the striae, even though they're very fine, and the raphe very clearly, of course. So I think that's it'll make a nice picture. Tickling the focus. Yeah, Staros is the structure, right? Let's see. Well, it's drawing a nice image of it. It's really hard to see those very fine striae. Did I eat lunch? No. And it's 3 o'clock. I've been streaming for about 2 hours. I have this bottle of Dr. Pepper. It has sugar, so it's kind of like lunch. I spent my morning sort of getting the SEM fine-tuned and taking some pictures. And between pictures, I was helping my student Addison with her poster. Addison and Laura, my two master students that have active research that can do presentations, are going to Portland next week. They're actually leaving on Saturday, and then they'll be presenting at the annual meeting of the Geological Society of America in Portland, Oregon. And so Addison's presenting a poster on her work, which you've probably seen bits and pieces of if you've been in the channel before, and Addison has also been here using the SEM for a while, from the diatom record from Clear Lake, Iowa. And earlier this summer, Carlin and I went and collected some samples from Clear Lake, Iowa, from modern sites and stuff. So we sort of talked a little bit about that. And then Laura is presenting some of her research on the geospatial analysis of some diatom data, and it's data that I actually analyzed, but that Laura did all of this sort of statistical analysis looking at the kinds of environments where we find diatoms, and some multi-linear regression trees showing what's controlling the presence of one diatom versus another, and then a bunch of statistical analysis on the modern sediments that we see, so that we could use that to basically figure out if we were going to collect a core and we wanted to reconstruct something like lake level, where would be the best place to core, and also to tell us something about where those diatoms are typically found in the lake systems that we have, because we think that her lake, Gull Lake, and the lake that we'd previously analyzed from June Lake used to be together as one lake. And eventually we're probably going to write an NSF grant to try to solve this mystery, and knowing where the best place to take a core would be really great, but also it gives us some idea about the diatoms that we see in the core and what they mean when we see benthic stuff. Instead of just saying, well, it's shallow water, we can actually tie it to which part of the lake were those diatoms found. So as part of our paleoecological analysis, that's really critical to actually go into the modern environments and try to figure out what controls the distribution of diatoms in those settings, so that we can more clearly apply what those mean when they show up in the core. So if I have a whole bunch of Amphora, for example, in the core, and I want to know like where was Amphora living today, it's useful for us to look at those modern environments and be able to say, oh, I see, today it lives in this one side of the lake where it's a little bit rockier. And so the modern samples are actually useful for us to do that. I think it's also the last significant amount of counting that I did recently, where I actually was counting diatoms. Most of the time I'm just making other people do all the work and then stealing all of the credit. So here's an internal view of that same star anise. This time I did all of the work and I'm letting Laura steal all the credit. So, but then she did a bunch of different work associated with it. And you can see here's that Staros structure. It's a solid piece of silica. I know that we're looking at the inside of the valve, not the outside. If you're wondering how can I tell, these really bright marks on the outside edge are because the edge is curled towards us. And in the other one, they were dark because the edge is curled away from us. So you just get some clues when you look at stuff in the light microscope or in the SEM a lot that sort of give that away. And then this little guy right here, who's friends with this star anise, looks like it's an Ensinema. Yeah, that's an Ensinema. So the raphe comes and curls downward. It has some interesting... Those are some pretty interesting pore covers on the areolae. They're sort of X-shaped. I'm not familiar with this particular Ensinema in the scanning electron microscope. The image is kind of messed up because this grain right here is super bright and it's creating a dark band. It's then expanded over our diatom, which isn't completely cool with me, so I probably won't take that picture, but that's a neat diatom that I should look for. And then I saw up here a little tiny diatom. Oh my goodness, is that a tiny diatom? That is Stephanodiscus, and I think it's Minutulus / Parvis. Here you can see the strutted process. We're looking like into the valve, so normally this is not a very easy thing to get a picture of for Stephanodiscus because they occur right on the bend for the mantle face, valve face interface. And when I change the beam intensity down, you'll actually see a lot more of the detail associated with that structure. There we go. So strutted processes get their name from the fact that they have a central pore, which is this piece, and then some little satellite pores that go around it with these little coverings over them that make them look kind of triangular sometimes when there's 3. And then you can see these are dome cribra. The little areolae have little dome cribra on them. And that's a really tiny diatom. The valve diameter looked like maybe it was 4 microns. So a really, really small little diatom. You can actually see, because I have the stigmation on here really nicely tight, that the area around the strutted processes has a bunch of little tiny holes. These are like little cribra from these really tiny dome cribra. They have like little salt and pepper shaker heads on them. Very cool. I'm actually at about 90,000 times magnification. I'm going to zoom out a little bit. We don't need to be quite that close to get the whole field of view in. Let's see if I can still keep it, work on getting that image a little bit tighter focus. We'll do much better than that. See how it's gonna look. It's okay. Let's see if I maybe change this to 6 if we get a little bit better. Not bad. Cribra pillows. Let's see. At least you can go have lunch. Well, sort of. I mean, I guess I could leave everybody. I'm looking at a sample that was collected in June and not preserved. Oh. You'll probably have breakfast for lunch. Oh, what we had in the picture was more or less what was in the colorized one. It's cool. What is your favorite breakfast? A tie between brioche French toast and breakfast casserole. I'm gonna go with the French toast. Aldi has a chocolate chip brioche that I'm dying to make into French toast. Ooh, that sounds fancy. Alright, this is looking good. I guess I should just go ahead and take the picture. Oops. Yeah, that's good. I've got these new software tools for photography that are the Topaz Labs toolkit that I've been playing around with, and most of my pictures are in pretty good focus, but I'm dying to put something into them that is like slightly less focused than perfect, like some of these really high resolution images that are zoomed in, because you can't get the focus any tighter without going like a much longer exposure, and then seeing how well it can turn them into something that I could use. So we'll see if I can sharpen this image using that, play around with it. So that's my plan. See if I can turn this into something that looks just a little crisper, which is what it needs, to be honest. Part of the problem is it's standing on its edge. Part of the problem is I'm only using beam intensity 6, when normally I would probably take it down to 5 and do like a slightly slower picture if I really was trying to get all this stuff in detail for publication. But you know, some of the stuff is just out of focus because my depth of field is so shallow, right? Like the cribra that are up here on the top side edge are just out of focus because they have to be. So I'm just sort of curious what it will do with this. So it'll be a good test to see how well it handles the SEM images this way. And if it works out nice, I'll probably colorize this and we can put it up, give it to the bed and breakfast hosts as well. So yeah, we scaled back to only 83,000 times. Now you know where to look. You're cheating. We'll see how good I can take a crappy picture, how nice I can make it look. It's not crappy, it's just not great. It's not up to my normal quality. It's got a lot of cool detail though. Okay. There is a little stuff in the lake, and I knew that. I think it's Stephanodiscus minutulus. But we know that we have the SEM's stigmation pretty good, because all of those look nice. Okay. We've actually only been on one of these samples the whole time. And I have 3 of them. But I think when I was looking around in them, they more or less had the same kinds of diatoms in them. I didn't see a lot of variation, but I think there was some large Cerulellas in this one, so we could maybe take a look at those. They were covered. There was some mud on them, so maybe not as nice as they could be. And I didn't look for any of the small things. So this is that Pinularia, same one that we've been seeing. It's pretty common in these materials. This looks new. Oh, that's just a fragment of something. Not sure what that is. Still not sure what that is, actually. I don't think it's a diatom. Unknown. Bit of a mystery. Here's that not Navicula that we saw in the other sample. Starcyra. Or Fragillaria, maybe. Fragments. Unidentified tiny object, yeah. What's this? Not totally sure. Yeah, not totally sure what that is either. Some weird objects in this stuff. Could be a diatom. Hard to tell, it's got junk on it. See, they start to glow from the fact that they're up off of the surface, and they have a lot of sharp corners on them. So we were talking a little bit earlier in the stream about how edges, corners, basically are areas where electrons can accumulate in a scanning electron microscope, and they tend to distort the image a little as a result of that. So, Melisira, again. We've seen a bunch of in this sample. It's the inside of a diatom of some type. I can't see because it's filled with little tiny pieces of silt. So I can't see much of this diatom, but I can tell you what it is. Because the structure of the striae right here, we've seen a bunch of these in previous streams as well, so if you're familiar with the channel, if you've watched them, you would know. These little clover leaf-like structures happen only on epithemia. These are epithemia areoli. And so even without really seeing the whole diatom, it's all on the other side of us. I can tell just from seeing this much of it that the other side has epithemia. Has to be. We only want to have these really intricate structure to their areoli that look like little clovers. Here they are. I'm gonna just play with this a little bit and see if I can get the image quality to be a bit better. Start by brightness contrast, and this image now has super high contrast. We'll just take a picture of this texture, which I really like. Hey, Commander Shafard. How are you doing? Tiny objects are very mysterious. That's true. Always with the junk. They glow with the residual demon's blood. Commander Shafard, we looked at a cricket in the SEM while Pacific Plankton was here in the lab, and I counted that as a grasshopper. So, because we tried to catch grasshoppers while she was here, and it was challenging. It kept running away from us, like it didn't want us to sacrifice it. But there was a grasshopper that jumped into the bucket outside my house and it just sacrificed itself, and that was easy for me to catch and bring in because it was dead. So I didn't have to kill it, and then I just was like, close enough. So hopefully you can go back and watch the VOD and find the cricket, and you'll feel like that was suitable. Because I don't know if we'll see any other grasshoppers. We'll see. Headshot, hello, how's it going? Let's see. You split your pants and you were 10 minutes late for work as a result, and then you hit every red light and got caught behind slow drivers, and it turns out you didn't even work today. That's a rough day. Well, do they let you eat at your work? Could you go there and just eat like lunch or breakfast or whatever it is where you are? You know, so at least you're there, you could get food, right? Also, you weren't late for work, so there's that, because you didn't have to work. I think that's a plus. You went to McDonald's. Did you see Mayor McCheese? I'm asking for a friend. Oh, they have the Monopoly again. Oh, yeah. Was the Mayor McCheese there, though? Hey, we made it to the end of that image. Good. And nothing bad happened. It's an epithemia on the outside girdle view. Perfect. That's going to be a nice coffee table piece for somebody. See how well I can make it look fancy so that the people who Pacific Plankton stayed with when she was here will continue to let us potentially use their canoe and lake if we want to go back. They said, you can come take a core at our house anytime, come collect samples, whatever you want, and then we threw mud all over their driveway, so I don't know if they still felt that way afterward. It's question mark. That's all I'm going to say about that. I mean, if I was like, come over to my koi pond and do whatever you want, and then you got there and then the response was accidentally throwing mud all over the place, maybe I would uninvite you. I don't know. Actually, mud's easy to wash off my driveway, so I probably wouldn't mind. There's a girdle band of something. It looks like maybe it's a Symbella. I can't tell. It's large and only partially exposed. I saw one. I saw a giant Symbella just a second ago. I didn't imagine it, did I? No, it's right here. Look at this guy. Wavy Cerarella. Also covered with junk Cerarella. So I think that's what this is. I suppose it could just have a junky surface. No, that's definitely clay. This one was... It's got a cool texture. It's got this sort of like rumpled surface. But it's so rumpled the mud didn't come off of it. It's the demon's blood didn't want to leave. So you can't really see the surface texture. Just see the
Hey, Maui,
outline of it.
Souri.
I think this is Cerarella ioensis. And I guess that because it looks like the top part of the valve up here and the bottom part of the valve down here are torsioned. Hey, did we get raided? What happened? Mushroom mentor. I gotta come back and look and see what happened here. Hang on. Mud washes off, but it doesn't wash off very well. Mushroom mentor. Subscribe with Prime Gaming. Thank you, Mushroom mentor. That's what happened. Oh, for a second I thought it got raided. It was a bunch of like stuff flew over my screen. Wait a second. We did get raided. Hey, Cosmo Quest. What are you ladies up to? Were you... look at all that. Look at all the stuff that went all over the screen. It's crazy. Rockets everywhere. Veronica, hello. And how was the stream? What have you guys been doing? You were looking at rockets? Is that what happened? You know, I got this thing. I can fix this. I can do this. Cosmo Quest X. There. There you go. Gave you a little diamond. I gave it to the Cosmo Quest account because I don't know who to give it to, but now you've got a VIP. Podcast recording. Okay, time to go off and get it uploaded. Okay, thank you for bringing some people in. We're looking at some diatoms that were trapped in a lake filled with demon's blood that Pacific Plankton, when she was here visiting, dumped all over the people she was staying with's front driveway. And this is a Cerarella, I think ioensis, that was in the core that we collected. And right now we're looking at diatoms and the mud that they're found in the scanning electron microscope. It's what I do. While we talk about breakfast foods and who knows what else. This is star anise again. I think it's the same one we've been looking at. Let's see. The big ones are easy to find if you zoom out. You can kind of see the diatom shapes. It's Where's Waldo, right? But you can easily find the shapes that are geometric and go, oh, that's a diatom. It's a Amphora again. And this time it's got both of the valves. Last time we did it only had one valve, but it also had the girdle bands. But it landed on its back with its raphies up at us again. And we made this one look like Mary McCheese earlier. We put googly eyes and a mustache on it. So let's see. Close that. This is the same diatom. It's the one we started with, Amphora. Yeah. It's in that song that Hannah Rebecca Music sings. about my channel. She recently added a whole bunch of verses to it with new parts, and while she still hasn't recorded it for me, that was like a promise that she would made when she first made the song. She was like, "Oh, I'm just gonna keep adding stuff to it." So if you haven't heard the song sung by Hannah Rebecca Music, the Diatom Attack song, when she streams later today, she said she was at the doctor's office or something, but when she gets back from that, presumably she's going to stream, because she said she was going to stream today. And then you could go request that from her, and you could hear the extra verses. See their little X shapes? It's that Ensynema we saw earlier. In here, the little areolae are kind of like X-shaped. This one also has like a weird shadow from the rock that's behind it. It's also like floating up here well above the surface, so it's going to charge up probably if we leave the beam on it for too long. But it's that same Ensynema. I suppose if I was very patient and looked through all of the sample, I would be able to find it, you know, a clear example of it. This one is a Symbella, closely related to Ensynema, but some clear differences. One is here at the end, at the distal end, the raphe curls upward instead of downward, which is the one that we saw curling towards the ventral side. This one curls towards the dorsal side. And you can also see that it has a very, very pretty apical pore field. The raphe curls right along the edge of it. I guess there's a little bit of it up here, where the little holes are different than the rest of the little holes on the diatom. And also you'll note that the striae here are different than the one that we saw. So these ones have what we would usually call lineolate striae. They're dashes, but they're perpendicular to the, they're parallel to the raphe, perpendicular to the direction of the striae. So these rows are what we call the striae. And then Symbella also have, often, if I can get to the middle of the diatom, it's a very long, elongated diatom. So this is the central nodule, which has the raphe, proximal ends of the raphe, the close ends of the raphe, and then it's got these little things. Those are stigma. And you can see the X shapes also occur on these striae when you get away from the edges. So they start off as lineolate, and then they actually turn into little TIE fighters and X shapes, and that the stigma on these is always on the ventral side, the belly. We sometimes look at Afrosymbella on the stream, diatoms that are exclusive to Africa, and they're kind of like these, except for this marks are on this side of the diatom, on the dorsal side, not on the ventral side. Cool diatom. This is Symbella, like a cymbal, you know, like the kind that you would play in a drum kit. Cymbal shaped. Easy to remember the name if you know what a cymbal looks like. Oh, there's another little amphora right there. Got another Mayor McCheese, only this time we can see the whole valve face, and then part of the other valve face. Yeah, there's the song. It's always the TIE fighters and the X-Wings. Yep, it is. It's a cheerful diatom. It's got a mustache and a smile. You're gonna have to go in a little bit. Well, we'll miss you. It's 2 hours and 40 minutes I've been streaming. It does seem like I've been on for a while. And now it's too late to actually go eat lunch for me, because then I'll ruin my dinner. So I don't know what to do with that. I could go get a snack, I bet. Need to be a taxi service. What you could do is run a taxi service from your car. You could drop your kids off, and then you could pick up somebody who's actually a passenger that needs to come back the other direction. And then you could make money off of the deal. Yeah, Uber skills. No? Well, you could just charge your children to drive them places. You have a messy car. Well, you just get 1 star every time, but people who are desperate will ride with you. Plankton nets. You're an Uber for plankton. You pick them up and bring them home. This has got a bunch of glitches in it. I don't know if I can fix that. The diatom in girdle view. I think it's the star anise. It's an internal view of that Pinularia we've been seeing, the same one. See, a lot of diatoms are in this sort of outer part of the meniscus that dried, the sample dried, and there's sort of like an edge of diatoms that they're all trapped out there where the water droplet was, the margin of the water droplet. Alright, let's jump over and do the one last sample of demon blood stuff here. And then maybe a little bit of time with Gull Lake, if we can. Oh, there's a straight into a Symbella. It's right here when we started. That's nice. It's covered with mud, which is not so nice. But you can actually see some of the structure on this one. They have this like really interesting little hexagonal network on the surface of this diatom. It's Symbella labrile. It's the species. And you can't really see the mud so much when you're zoomed way out, so we'll probably just live with it. You know, I was thinking the other day, I haven't seen Mr. Horologist on Twitch in a really long time. It's been at least like a month, I think, or more since I've seen him. He's always used to be coming into Pacific's channel late at night and raiding. Maybe he is on vacation, yeah. You never know. I mean, I guess people would know if they asked him. I feel like this diatom would benefit from googly eyes, to be honest. The question is, how would we do the googly eyes, you know? Like, if you had to googly eye this, how would you do it? I think that's an important question. Oh, I guess we're gonna find out. Yeah, he was working on his car or something. Alright, well, since Pacific's gonna make me do it, now we gotta figure out where the googly eyes would go. We're forced to. We put the googlies on it, and then, you know, the question is, if you have to googly eye this diatom, do you googly eye it like way out here, like super wide, one on each end like this? That's pretty googlied, you know. The anticipation to see what the other eye is doing and where it goes is killing us. But we could put it all the way out here, and it kind of looks like the edge of an eye, like a hammerhead shark, you know, way out on the outside edges. Or it could go here, like a fish, or it could be really in the middle. That's Pacific Plankton's other model. Or what if we did like flounder-like, you know, like a flounder? Or you could do it like that, you know, like there's a lot of googly eye options, I feel, for this one, and they might all work equally well. If we did it like that, you like that? Both on one side? What if we made it like one eye bigger than the other? That is extra googly. What do you think about that? Oh no, it's moving. Or we could do it like an alien. They don't go anywhere that makes any sense, you know? Now it looks like it's perspective. You don't like the, like, on both ends hammerhead shark? Or like this one where we put the googly eyes in the middle? There's no reason for that to be amusing. But is it? That's the only thing I have to ask about that. Is it amusing, though? Grand Masterong. It amuses you. Yeah, that's all that matters. If it makes Pacific Plankton happy, then she spent the points, right? She threw down the money for it. So let's see. This is the time money. This is, oh, sorry, it's Sorella now. Sorella Labriel. And then I need to just to zoom out a little so we can compose the googly eyes correctly. I feel like that's a critical step. And now, you want them like, did you want them like this? Like a worm? This is where you wanted them? Let's see. If we... There we go. It looks a little less crazy now. It doesn't have like a lazy eye. That seems appropriate. Yeah? We can just stick googly eyes on anything. We could actually googly eye, like, you know. That's the thing about googly eyes. They could go anywhere. And then you'd be like, oh, that's cool. It's a pet rock. It's nice. It's a nice addition, right? Now we have eyes and a mustache. And then gives me something to do, you know, for fun. People got all these points from watching my stream for a long time. I feel like we ought to entertain them with it. So, here we go. Just in case you were interested in seeing the hammerhead shark version, there's this. That makes it look like there's just one eye. And then this one. I feel like if we were going to do that, we'd want it on one side. And then maybe we would want to bring in one of those mustaches, you know? We got the upside down Fu Manchu going on. That's not going to work. I got an upside down mustache now. This needs to be like 180 degrees higher than that, though. I don't think we want an upside down mustache, but maybe we could just move the eyes to the other side. Yeah, that's the easy solution. There. Doesn't look too bad. You like it just like this, though. This was your preference. Very wormy. Perfect. Okay. I feel like we've had it. It's good fun. You like the worms, of course you do. This is Sorella Labriel, as I mentioned. Looks good in the picture here. I did an okay job with that, and with the googly eyeing. We had some important googly eye decisions to make, and I feel like we did a good job making them. It's a collaborative effort. Look at this. There's a diatom just sitting out here, gloriously uncovered with anything, and already turned almost to the right angle for me to just go ahead and take a picture. I maybe need to add 10 degrees. A perfect little navicula just sitting there on this stub asking me to get its picture. Very nice. Gonna look good. Very, very, very good. No junk on it, totally clean from mud, just sitting on its own, completely flat on the stage. Gotta love it. Alright, we'll see you later, Pacific. Oh, maybe Hannah will come on and we'll hang out in that chat later tonight. I don't know when Hannah was planning on streaming, but when she gets back from her doctor appointment. Hopefully everything is good. It's a very weird structure on the end of these apex. Like, what is this thing? Huh. So the little dots that are all over the surface are granules. These are the areolae. They are lineolate striae, so little lines that are basically parallel to the raphe, or perpendicular to the lineation if you'd like. And then in the central area, they are radiate. In other words, they are pointed outward from the center. And right about here, they are essentially parallel with the valve, or perpendicular to the axis if you'd like, the apical axis. And when you get out towards the end, just slightly convergent. In other words, they're pointing towards the apex instead of pointing outward, like these ones. So outward, parallel, convergent. And these are the proximal raphe ends, which dilate very slightly in the center, in the central nodule. And then these are the raphes. The raphes have really cool endings on them. They kind of go out and bend. And then they get kind of square for a bit and hook back. And this structure's on both sides of the valve. I'm not sure what that is. What are these little slits? I'm gonna have to look at some pictures of Navicula. What are those? Very weird little slits. I don't think I've ever seen anything like that before. Very strange. It's definitely some sort of structure. It looks like it goes all the way through. Doesn't seem like it's just a malformed areolae or anything. Super weird. Alright, so I think once this image is done, we'll take a quick look at some stuff from Gull Lake, and then call it a stream. Probably another 15 minutes or so. These samples are really cool. And I feel like I got enough things to use as photos for doing some stuff artistically for the people who let us use their lake and their boat very generously. And they were also very curious about what we were doing and what diatoms were, so it's kind of nice to be able to do a little here's what we found in your lake kind of interaction with them. Because people don't need to be that generous, you know. There's no reason for them to necessarily like just let someone borrow a boat or whatever. You know, so it's nice of them. So I would like to be able to give them something nice back. This is another epithemia. No, that's a Sororella. We're just looking at the Sororella from the side. It's the girdle band, it's broken off, and you can kind of see in between into the actual diatom. It's a Pinularia. Here's another one of these Sororellas, a different kind. That's a Pinularia again. So all the really big things are, there's a bunch of them right here in the middle of the field of view. That is another epithemia. Again, if we get in close and we look at the areolae, epithemia have very distinct sort of clover-shaped or little C-shaped epithemia areolae. Let me just get right in real close and look at those. Kind of cool. And there's the Raphy actually running right along the outside edge in this little sort of lip shape. This is Epithemia giba. It's a very long epithemia. The ends are bowed out a little bit. It's a little navicula, maybe? Those are navicula striae, so it is definitely a navicula. This like ball-shaped end, a capitate end on it is kind of cool. You can see the raphy, the terminal end of the raphy. Kind of follows the shape of the outside edge of the diatom. This one has some junk on it, otherwise I probably would take a picture of it. Thought it was going to be sort of clear because it's out in the open, but still had some clay covering over the surface. It's probably Pinularia again. A lot of times they end up in girdle view like that. It's a fragment of a Pinularia. Star anise. Oh, there is that other Sororella that we saw on the other side, the one that was two halves. This is what it looks like in the valve face view. This is the external view, and then I think that's the other valve behind it. There's the raphe, I think, for the valve behind it. So we have the whole diatom here. Not a lot of ornamentation on it. If we zoom in, there should actually be little tiny holes in rows. They're just so small. Yep, you can barely see them. Here they are. And I think we're on beam intensity 7. We'd have to probably take it down at least to 6 to see that structure clearly. Maybe 5. In a way that would actually allow us to kind of see the detail. You see that whole surface is like covered with little tiny holes. 2 chooks, hello! As a texture, that's maybe perhaps satisfying, but you can just barely see them when you get out to the scale of the actual diatom. You've drawn a few diatoms, blue ribbon. Oh, is there someplace we can see the drawings? I like that. I think you can post links because you're a VIP, but I think actually maybe anybody can post links. But I'd love to see it. really like this, the way that it interacts with the. These features are fibullae. I really like the way that the rows sort of interact with it. I think there's a very satisfying feel to it to have them come in and just hit the structure and like wrap around it. We'll do one more photo of this, and we'll skip the gull stuff. Focus. You can just barely see those little tiny dots all over the face of that thing. What if we did like maybe this part of it? My colleague just told me about this channel. It's amazing. Oh, thank you, Lisa. Welcome in. We've been streaming on Twitch for over a year now from the Scanning Electron Microscope. Sometimes I just do photography, sometimes I do some photo editing, sometimes I'm doing stuff from the light microscope. But a lot of times we're streaming from the Scanning Electron Microscope, looking at whatever. A little earlier today we were looking at some mouse jaws and shrew jaws in the Scanning Electron Microscope, so very small critters that a owl had regurgitated because it couldn't digest the bones and the fur. So we looked at a little bit of the fur, we looked at some of the jaws and teeth, and then these are some samples that we collected from a core. I'm actually a diatomist, so I study diatoms. But we look at all kinds of microscopic things here, including pollen, and we've looked at phytoliths, we looked at sponge spicules, we've looked at, basically if it's small, we look at it. A lot of times I just try to tie it together with research that I'm either working on, because I'm a scientist, or my students, if they're working on the Scanning Electron Microscope and they don't mind being on Twitch, then I let them actually be engaged in the operation of the SEM during the Twitch, and then I usually just handle the chat, and they can talk a little bit about their research that way, so it's kind of nice. And for anybody, so earlier we got a subscription. Anybody who subscribes to the channel should know that all the money goes towards student research in my lab. So either buying supplies for the SEM that we use for the stream, or for buying supplies for actual student to do research, scientific research in the lab. I feel like the brightness is there the way that I want it, but I'm not sure that the focus is still there. Seems like it's just a little off. There, that's better. Should be able to see those little openings, like somebody spilled Cheerios in rows. And I'm just gonna zoom back out so we get a whole the Raphy complex and the keel, and then you can see all that detail. That's nice. And we're going to go speed 8, which is the slowest speed that I use on Twitch. It's a 10-minute photo, but gives me a chance to sort of say my thank yous, because we're getting close to the end of the stream here. And oh, 2 chooks with the diatom pictures. Oh, there's a whole bunch of stuff here. Very cool drawings. Very neat artwork. I love it. Beautiful. Give it a click. I don't think that 2 chooks does any streaming, but or at least I've never seen them stream. But very, very cool artwork. Because I'm using the computer attached to the SEM, I can't really show it, or I would actually pull it up for people. But give the link a click. And check out 2 chooks artwork. 2 chooks been in the channel, hanging out with us for a really long time. Checking in occasionally for the streams. So, very, very cool. I already figured out who I'm going to stream. Hannah's not on, and I want to sort of stick with microscope stuff. So if you're here watching the Microscope stuff, sometimes we have other Microscope streamers that are in the channel with us. One of those earlier was Pacific Plankton, so she's also my moderator. And if you're interested in any kind of Microscope streaming, here's a whole bunch of really great Microscope streamers on Twitch. And Dell was here earlier as well. He's also a moderator for my channel. 2 of my close friends from Twitch both stream Microscope and other things. Pacific's mostly looking at stuff in the Microscope. And then OpenSet, who plays music and also looks at stuff in a Microscope and does a bunch of like kaleidoscopic 3D cool visual edits to his stream. Very, very fun stream to hang out and watch. Freckled Science is and Spider ID, 2 really well-known Microscope streamers. Freckled usually is building stuff and taking things apart right now and doing a bunch of sort of electrical stuff, which is cool. And Spider ID just streams them doing spider stuff at work. So you can see them using a stereoscope and looking at spiders and that sort of thing. And then Fizeria's on there. She's actually a musician, beautiful voice, does great streams for music, and then occasionally she just whips out a microscope and starts talking science at people, which is really cool. And then there's some people down here a little bit more infrequently stream that I would like to draw some attention to, and one of them is who we're going to raid, Porcelain Giant. So they just started streaming with their microscope, and I want to try to support other people who stream with their microscopes here on Twitch. So that's who we'll give a raid to. And then Line Wizard, I saw them a couple of weeks ago on stream. District 10 is not in that list anymore, but they sometimes do some stuff on the microscope streaming. Protozoan Princess is another artist who does some microscopic drawings and then sometimes has stuff on that she's drawing on the microscope in front of her. Jelkson's also on right now. Jelkson is another microscope streamer who's on regularly, and you should give him a check out. Nid sometimes streams from the microscope as well, and Pengaline. So those are some really great people. The list grows every time, and now I'd have to have like a second command. So I think it's a great way to check out all of the microscope streamers, except for there's some I had to sort of make space for, because there's so many now, and I think that's great. So anyway, we'll give our raid to Porcelain Giant, and I thought that I saw they actually had some microscope stuff up. They do. So that's of course ideal for us to go straight from microscope stream to microscope stream, and also because they're new, they don't have a lot of followers, and so I really want to try to draw attention to that. So please hang out, stick through with the raid, and at least check them out. Thank you for following, Lisa, and for the subscription, Mushroom Mentor. And we had follows from JTech Pet and Gakiru, and we got a raid from Soundscape, and we got a raid, of course, from our friends Cosmo Quest X. Both of them brought in their streamers who hung out with us. We had a follow from Heg Pets and from Crixodia. And I want to say thanks to all those people, especially the subscribers and the people who followed, and the people who are always here, who hang out in the channel and make it fun to have conversations. Bring up a bunch of great things like Tuchuk and Pacific Plankton and Del Maximum and Devil and Mrs. J and Commander Shafard, the regular headshot specialists, all the regular people who come and hang out, Freya's Fury, and my friend Sarah, who's here in the lab. Okay, we're getting ready to raid. Thank you for hanging out, and please stick around and check out what Porcelain Giant's got on their microscope, and that'll be fun, hopefully. So, very cool. And keep watching science on Twitch, I guess. I'll turn these into a thing from my Instagram as well. So you can check that out there.
Diatomic, tell me what specific